Welcome again. I'm going to continue with the intersection tools, which I think are some of the most essential, especially starting out in the mathematics and early physical shapes. We're actually into the physical shapes. We're going to cover BREP all the way through to BREP split and do a couple of algorithms with them. It's great practice to go through and do this yourself. You don't have to follow my files. Sometimes it's nice to see someone else how they do it so you can have some ideas when you go into doing it. So basically, starting with BREP, I pulled this in with these little jump tools that come out of the params. I like to use this. I'm trying to find a system that's very helpful for people. Jump tools are over here. And what happens is you click one and it'll shoot you in the script where it's being used. And then you can click and then go back to what the node was that you want to practice. And then this one down here is being used again. So let's take a look at that first script. Let's leave this and have a look at what I did. Basically, I brought in a circle. And I brought in a polygon. I put a surface on both of those, and then I simply dragged it over into the BREP, which is a boundary representation. What comes out are curves. No points come out because no single point is connected on those BREPs, and it actually moves through just the curves only or the intersection point. Continuing right along, I also took a cylinder and capped it along with a sphere. So you have a cylinder and cap, and you can see where they come in contact with one another right along the base of the cylinder, because that's just where it orients itself to the world plane. There are no single points, so there's none that are recorded. So let's go into the next tool, which will be the BREP curve. And BREP curve is going to be used here. Pretty simple. Didn't do much to it. I pulled down the boundary representation of the cylinder, and I brought in a line. And I actually imported in a line because I wanted to angle it and have it up. I find that's kind of boring, and there's not any practice in that, in making a line in Rhino and then setting it. But for this one, because it was so similar to the top one, it showed evidence of using a BREP curve that didn't give you curves that connected. It gives you the intersections of where the points connect on those two. So that's just the difference. I did that fairly quickly. The next one I wanted to get into was the surface curves, and that's kind of nice. It gives you a ton of information. Gives you a ton of points. There's no curves in this one for similar reasons, and it gives you a lot of normals and tangents. Great tool, surface curve, to start analyzing. One of the tricks with Rhino is definitely being able to make curves, make beautiful curves. So what I've done is I've gone in here and I chose a plane and I rotated it. That was pretty simple. So that's my thing that I'm going to intersect. Now, how will I intersect it? I thought I'd make a point, and I bring in a range that runs through a domain, and this is not the practice I like to do. I like to actually grab a mathematical domain and then make that the top of my domain. That way I can control the start domain if it starts at 0 or has to start a little bit above that. But that said, you have this surface, and I'm bringing in a sine curve, which I could very well have just dragged this down, and that would have done the same thing. But I was playing with the maths in this equation, so when you go in, you can actually have full control of typing out whatever you want in here. And that's what I was playing with, but I ended up deciding moving it back on the z-axis and giving it a helix in the z. So I generated something like this, which kind of, it's hard to see in context to the surface, but you can see how that kind of flows through that surface at some interesting twists and points. And to complicate that, I certainly made it a curve by using a interpolate, but then I threw it into a polar array, which generated all these crazy little curves that kind of spin through it. And it spins from the top view, that polar array, like this. So all those points are hitting this surface somehow. And of course, the great tool is the surface curve analysis, which tells me specifically no curves are connected, but look at all the points that come in contact with it as I do that polar array. And if I was to change the count of that or do anything within that, you're going to see the effects of that on, let me just keep this going, that surface and what points are connecting with it. So now there's only 2, and as I slide it up, you can see I start to hit it more and more as those curves start to slam through that surface. So that's where things start getting interesting. You also have excellent information coming to you when it comes to the parameters on those lines, or where it's hitting, so you can use those parameters to funnel into geometries, to have geometry start at those points once you've located the curve, because a curve only needs one parameter, t, to tell you exactly the space where that is. And you don't need UV points, but this actually gives you UV points also on the surface, which is pretty awesome when you start joining and thinking about lines and surfaces and what that means. I'll keep going. but these are tools for thought. And the last one is just a quick uh, split surface. And what I did was jump in here and made it down here. So I'm going to split a surface. And I look at the little icon. And I'm like, okay, well, that's pretty simple. I already had a surface up here. But I thought, well, why use that? Why not go in and take this curve and treat that curve as the surface? So I threw it through an extrusion in the Y positive and negative direction. So I can actually extend it out. But that becomes the surface that I want to shoot a curve through. So I actually did that and decided, well, let's take this curve that we had, and let's analyze it this way and bring in a second curve this way, and actually started using this as the splitting curve. And you'll notice it doesn't actually it doesn't compass up and down on it. It doesn't go side to side on it, which is interesting, but it still analyzes that curve as a way to fragment that. And what I used is a dispatch, but I had to flatten the data. I didn't want it to come in as a grafted list of two things. I wanted to flatten it so I could separate it into A and B groups. And there it is, A and B groups. You can see that in my image. So really, have fun with these very simple scripts. You don't have to make great geometries, solve client issues and things like that, but all of these simple tool sets as you go through, especially in the intersections as you come to understand them, move through the mathematics, critical to get your head around those tools, which we did in the last video. And then this video on physical, we're going to go into mesh curve and mesh. And I'm going to try to show you some interesting things that can be done with collisions points to analyze that. So we're going to try and get through these 5 on the next example. That shouldn't be too hard, but maybe it will be. All right, thanks very much for watching. These full files, which cover everything, will be in GitHub under M. Wickerson. Thanks very much for watching.